All right, we're going to keep going. We have the number of chloride ions in 3.64. So once again, we're going to summarize the question. N of aluminium chloride is 3.64 mole. And you need to work out the number of Cl minus ions. So already we can see a little bit of a not inconsistency. We have a little bit of an issue here. You cannot find the number of chloride ions unless you have the number of mole of chloride ions. So in order to do this, I do need to find N of Cl minus. Okay, you can't go. This is why I always have problems when students don't, if not summarize the question, at least indicate the number of mole which I'm looking at here. This is aluminium chloride. This is chloride ions. You definitely cannot use the number of mole of one thing to find the number of atoms for another thing, because the formulas are not consistent. So we need to actually go to an intermediate step to determine the number of mole of chloride ions before we can find the number of atoms or the number of ions. And in order to do that intermediate step, you just need to look at how many chloride ions are present in one molecule of aluminium chloride. Now you can use ratio or common sense, but for the sake of, for the sake of the argument, let's just write out what the ratio would be. If I want to make 1 aluminium chloride, I need 3 chloride ions. So the number of mole of chloride ions should always be 3 times the number of mole of aluminium chloride. Okay, which is 3 times 3.64, which is, I don't know, what does that look like? All right, I'm not sure why I did that. Why I did a multiplication by hand. So I'm checking with the calculator. It's right. Okay. And then, now that you have the number of mole of chloride ions, you can safely use it to determine the number of chloride atoms. Okay, so we have 10.92 multiplied with 6.02 times 10 to the 23, which is 6.57 times 10 to the 24 ions. Alright, so that's part C. And avocado is still kind of green, not ready yet.